Video, I'm going to graph f of x equals log base 4 of x. When we have a new graph that we do not know what it looks like, it's always great to start with a table. So that's what I'm going to do. Now, y is the same thing as f of x, our old notation versus our new. So if I'm going to rewrite this, I could call this, instead of f of x, I could call this y equals log base 4 of x. That's what we'd like to graph. What we usually do is plug in values for x. And this could be a little tough because what are you going to plug in? You have to plug in things that you know is going to work because log base 4 is not on your calculator. You could use the change of base formula and get into log base 10, but I'm just going to go ahead and plug in a few numbers that I know is going to work, like 1 and 4. Why do I know those are going to work? It's because I think of what the definition of log means. Using any letters, b to the a equals c, what we want is to get this into logs. So this means, so we write a log, the base is the b, whatever's underneath the exponent, so we usually put it there. The a is the exponent, and that's what log means. So if it's the one that's alone, the only letter that's left is c. So this right here is always the base, and the a is always the exponent. So now I'm going to go backwards, and I am going to figure out when x equals 1, using our formula, what does y equal log base 4, instead of an x there, I'm going to write a 1. So what does this mean? This implies that going backwards here, the base is the 4, and the exponent is the one that's alone, which is the y. That equals the 1. And 4 to what power is 1? We know the answer is 0, because anything to the 0 power is always 1. So when x is 1, y is 0. Let's try when x is 4. Why did I choose that? Because we can plug in 4. What does this mean? Y equals log 4. Instead of the x, we write 4. So that means the base is 4, same thing. The exponent is still y. This time it equals 4. So now what does y equal? Oh, y equals 1, because 4 to the 1 power is 1. So this is somewhat, you can see, you have to pick things that are perfect here. So if you don't want to worry about that, the other way to go is to get it into exponential form at the get-go. So let's go ahead and try that. So log 4 of x, y equals, means, what does this mean? Again, going backwards, the base is 4, just like up here. The exponent is y. This time it's equal to x. So why am I doing this? Is now I can use this formula and plug in values for y instead of x. So I'm going to plug in maybe y is 2 and see what happens. So if I go through here when y equals 2, what does this imply? This means 4 to the 2 equals x, which means 16 equals x. So when y is 2, x is 16. Okay, that's getting above my little scaling here because I'm only going to 10 on this graph. So I'm going to choose maybe a negative 1 for y. So y equals negative 1. What does that imply? And I just put a negative 1 into the formula circled for y. Very simple. I don't have to get it out of logs every time. So what does that mean? 1/4 is the definition of 4 to the negative 1 equals x. So we know that's 1/4. That's hopefully enough. Let's just try plotting those. So we get 1, 0. So when x is 1, y is 0. That's our first point. The second one, 4 is 1. That's our second point. 16 is 2. Well, that's way over here. That's beyond our situation. So I'm just going to plot this one. When x is 1/4, that's smaller than 1, about right there. We have negative 1. So you can see that the graph looks something like this. And by the way, 2 is 16, so it is close there to being 16. Maybe I have 10 being 2. So it's a little bit lower, but that's close enough That's a sketch of what the graph looks like.